This conference will now be recorded.
Okay, so the first tool in our tool chain will be Git. Okay, so Git is a tool. So it can be, some people pronounce it as Git, and if you some people will do it as JIT, right? So whatever it is, both are same. So Git is just a version control tool, and we will talk about what are the different types of version control we have, and what we had, where we are today, and how to work with that tool, and how to check in our code, and why we need this source control. This one, right? Let's start off. So version control system is nothing but a system which will document all your changes that you have made to your file, okay, or set of files, right? Say for example, if we are working on some file, and what you can do, you can track all the changes that you do. If you don't track those changes, what will happen if someone overwrites? They take the same file and they make some change, they will overwrite, then your changes are gone, right? So in order to kind of avoid that, we have to version this, or you have to document all the changes, or all the history of changes that has happened over period of time for a particular file or set of files. Very important is multiple users can use the same file, they can use the same code, right? So it can manage multiple revisions of the same unit of information. So that means, if say for example, I have a test.java file, which is what I'm working, and Abhinav is also working on the same. So multiple users can still work on the same file and have all our changes, and we know who has done what changes, right? So you can maintain those kind of uh, record those changes over time. So you know, like what you changed last year, or who changed what they changed, or if something new feature has been added to the code, what they have done. So all those things can be done. So it's nothing but basically a snapshot of your project over time, right? So say for example, if I'm checking in now, you take a snapshot. So at this point of time, whatever is there, and along with the previous history, everything will be there for your project. That's nothing but your snapshots. That is where your version control tools comes into picture. Now, before these version control tools, like the version control tool first started with like having our local version of your local version control system. That means what people used to do, people used to write code, and to just take a backup, they will copy to some folder in their own system, and they will kind of make the changes, right? Now, what will happen if the system crashes and say that there we are 5 people working the same project? I don't know what Abhinav is working. Abhinav doesn't know what I am working, right? Bala doesn't know what Abhinav is working. So it's very difficult to track if it is in our same system, right? But there was some kind of solution initially that was formed, like using a local version control. So many people's version control method of choice was to just copy files from to another directory, and they, if you are smart, if the developer was smart enough, he would have timestamped, he would have used the timestamp saying, okay, on 8th of October 6 p.m. this these changes I made, right? You will create a folder in that way and put everything there. But again, there's a problem with that, is like there are a lot of times there is a single point of failure, right? What will happen if you forget to copy some latest changes, or you accidentally overwrite the changes, or you copy a different file or a wrong file? So there is a lot of chances for errors, right? So in order to like overcome this, like, so they developed something called local VCS. VCS is version control system that had simple databases which kept all the changes of files under revision control. So if you would have remembered, we had like 10 to 12 years before, we had like CVS, right? CVS is called a control version control system, right? So CVS was one of the version control system we had, where they had this local database. So you, instead of copying it in your folder, you keep it in local database. Again, it is within your system. If your system crashes, that is also gone, right? So that was the problem we had. So this is how it actually happened when we were like 10-15 years before, right? So file was there in your local database or local computer, and whenever you want, you check out the version, make the change, copy to the new folder, and keep it there. And it was all very difficult to collaborate. I don't know what my teammate is doing. My teammate doesn't know what I'm doing, right? Even though we were all sitting together, right? It was very, very difficult. And just imagine the same scenario if we were in during now, when we are working remotely, like throughout the world, we are working remotely. It's very difficult for us to collaborate, right? So this was the first starting point for our local version control system. Then what happened? Okay, the next major thing that people were having the issues, that how do I collaborate within the team, right? So they formed a centralized version control system. Okay, that's a CVS. So they came up with the centralized version control systems. So these systems like for example CVS, Subversion, Perforce, these are some of the tools which were used for central version control systems. They have a single server that will contain all the files, all version files, a number of clients that you can check out in check in into a central place. So for many years, like 4 to 5 years or 6 years, this was the standard and we were using centralized version control. Again, uh, there are some advantages of having centralized version than local version, because if it's a local version, if your system goes down, if your system crashes, your entire code will go. But whereas in your when you have a centralized version, we can take a backup of the centralized database and have it somewhere else. So what will happen if that goes down? Also, it is possible that we can go and get those, and it is possible for the other team members to know at least to some extent what I am doing right in the team as part of the change or as part of the application release. What I am doing, they will at least come to know. So everyone knows to a certain degree what everyone else is in the project is doing. Administrators have a fine-grained control over who can do what, and it was far easier to administer a central place instead of going to each and everybody and asking their own files. There is a possibility that people can give you a wrong file, right? So it was very easy for the administrators also to manage the code. So as we spoke about in the last class, there was some role called release managers. So their main work was is to make sure all these are getting kind of integrated in one place, and they compile the code and then release it, right? It was a huge, humongous task for them when they had this centralized version control and the local version control system. Okay. So downside to the centralized version control system, again, as I told you, it's a single point of failure, right? It's a single point of failure that centralized server represents, right? So if the central server goes down, you don't have a backup, everything is gone. Okay, it is down for an hour, nobody can collaborate, nobody can save the changes, nothing you can do. Okay, if the hard disk crashes or get corrupted, again, if you don't have any proper backups of them, then again that's also an issue, right? So the entire history of the project, except whatever single snapshot people have, except that they will not have anything in the centralized database. If you have some snapshot in your local that you have checked out this morning, that will be the latest copy. Otherwise, your centralized database, unless proper backups are taken, that is also a single point of failure. So local VCS also suffer from the same problem. Centralized version also suffer from the same problem. Whenever you have the entire history of the project in a single place, you have the huge risk of losing everything as a single point of failure. So what they thought is, let's kind of move away from centralized version control to a distributed version control system, right? DVSS. That is what we are using today. Like, we'll go and see what is that. Before that, the centralized works like this now. Instead of you having everything in your computer, you have it as a central place, central server. Again, there is a single point of failure in this central server. Also, we saw that, right? So then came the DVCS. Okay, distributed version control system is what we are now using, and in this, the tools such as like Git, Mercurial, Bazaar, Darkus. There are so many things, right? So these are all the tools, and these are all used for your distributed version control tools. So here, what happens is you don't simply just check out the snapshot of your entire project, but you basically mirror the entire repository into your local. So each and everybody will have a local copy of the this one. They will check out the entire source code. They can into your folder. They can make their changes. They can check in. Others can collaborate. So many things can happen. So if any server dies, also if one of my system goes down, another system is already there, right? So there were a lot of things that the backup is already there. You can enable backup for these tools, and then you can have all your repositories backed up, and you can go and retrieve those data whenever you want. And you can also collaborate with different groups of people in different ways simultaneously within the same project. Right now, what's happening is, it's not only that my team 5 people are working in the same project. There are modules being written by different people. So DBS write DBA modules, right? And the presentation layer is written by the front end folks, and my business logic is written by somebody else, right? And all my configurations are taken care by, say, some engineers, some other engineers, right? So all this can be collaborated as a single project if we have this distributed version control system. This allows you to set up several types of workflows. There are a lot of workflows that are not at all possible either with a centralized or local version control system. And this is how it happens now. You have the server computer where your entire database is there. Computer A is my computer, computer B is Bala's computer. So what happens is every day when we come in the morning, right, we will download the entire, mirror the entire repository, and we both will have it in our system. We make changes till the evening or whatever time, right? And then we check in the code to one place in the server. And now since we have different people working in different location, different models, we have sun models where in the offshore in India, we work till evening 5 o'clock, 6 o'clock, and from 6 to morning 6, US folks take over, right? So they will go and mirror the database that what I have checked in. So they will have my changes also incorporated into their code. And they will make changes and they will check in and leave. And next day I will go and pull this out. So it becomes like kind of a continuous development will also happen only if you have a kind of a distributed version control system model. Otherwise, this is not going to happen. So if you would have remembered the DevOps infinity loop, so the continuous code build and coding and building will happen because of this only. Without this, it's very, very difficult for us to do this. Okay, so this is what will happen. Keep on, you can have a base version that's called a master branch. Okay, we call it as a master, and master is a working code that is currently running in production. So there is a new feature. What you will do, you will cut a branch from that master, make all the changes, test it out, then merge it with master and release it to production. So at any point of time, what is running in production will be the master. Okay, so that is what we need to keep in mind. We'll go and talk about all these branches and stuff, right? Any questions so far, guys? How this, what are the different version control strategies we had, and what is that we are having now?
No, Chandra.
Okay, now let's start with the actual stuff that we have to do. So we have to talk about Git. Git is the tool that we are going to use for our version control. So today we are going to install Git, and we are going to work on how to check in our code and how to play around with the codes, right? So Git is an open source DVCS system which records changes made to the files, laying emphasis on speed, data integrity, and distributed and non-linear workflows. They have a lot of non-linear workflows, and you have a lot of options to encrypt your data and so many other things. So many features are given in Git. So we will learn Git only to the extent that we need just to do our job. Once you get into an organization as a Git guy, right, you are a developer, then you will maybe need to learn more advanced into Git if you are working full-time in Git. But for now, whatever we are learning is more than sufficient to pass your interview or your normal work, right? You'll be able to do that. Okay, so Git is a free and open source distributed version control system designed to handle everything from small to very large and complex projects with speed and efficiency. It is a distributed source control management tool which allows you to track the progress of your development work by remote teams and open source contributors. It's not, since it's open source, you can also contribute to this project by writing more plugins. By if you are finding any bug, you can write a fix for it, and you can contribute to the community. So many things can happen, right? And even though Git is an open source, right, there are a lot of tools that are built over Git, okay, and they will sell it to the enterprise, like GitLab, Bitbucket, right? Bitbucket, GitLab, they are all source control tools. GitHub, right? They're all hosted on Git. So it underlying Git is the technology that is being used, but they will package with all the nice UIs and stuff and give it to the customers, and they will sell that, and they will provide support for that thing, because Git is an open source. The organizations cannot rely on open source directly, right? Say for example, you have a Red Hat Linux. We know that we know that Linux operating system kernel itself is an open source, so anybody can download Linux kernel, they can work however they want, and they can use it. But the problem with organization, if you are using that Linux, the open source Linux kernel that is available in the internet, if you download that and put it in production, if something goes wrong, there is no anyone that we can go and contact to get the support. So what happens is, the Red Hat is a company which downloads that, they put all the different tools and utilities into that, they package that as a Red Hat Enterprise Linux and sell it to the enterprises, and they will be responsible for providing any support that happens to that Linux, right? And the organizations will go for that. Similarly, for Git also, the Git core Git is an open source. Anybody can download, anybody can do anything. But this will not be used by our enterprises. So we will be using our GitHub enterprise license or GitLab, Bitbucket, and they are all the hosting services for our Git. And those people will, if we would have bought license from them, they will be supporting us for any issues with related to Git and GitHub and all those things. So that is the reason why the organizations don't go for open source. Okay. Okay. And Git is very easy to use. It's very easy. It's easy to use and maintain version control artifacts. You can do all sorts of things here. It's very easy to learn. Don't worry, there are only few commands. If you remember those commands, that's more than sufficient. You can save different versions of your source code and return to a previous version whenever you want, right? Suppose you have a v1.1.0 into a production, and you just put it to production v1.1. There is some issue, you can revert back to v1.0. Whatever is working in working condition, right? Immediately you can do that. So some of the features of Git, it provides various options for managing code repositories, collaboration between team members, and manage code bases and branches. You can manage a lot of code bases and branches. Now all open source code, whoever wants to contribute for Java or AWS or whatever it is, right? They will put it in GitHub, a public repository, GitHub, and you can go and pull those code from there and you can use it. Whatever is there in the GitHub public repository is open to public. So you need not ask anyone to download that and use that. Okay. So of course we'll also be creating our own public repository, and we will see how to work with this Git. Very important, this Git is integrated with famous IDEs, means integrated development environment, like Visual Studio, Eclipse, VS Code, right? Lot of tools are there like JetBrains, PyCharm, so many tools are there, and all these integrated development environments are integrated with Git. So from the tool itself, you can check in, check out, and do all those stuff, right? So that is the advantage. So some of the Git hosting services we talked about: GitHub, Bitbucket, GitLab, Azure repos, or AWS native code commit. They all work underlying Git only. Git alternative. What is the alternative for Git? SVN, okay, Mercurial, ClearCase, RTC, TFS. These are all some of the alternatives to Git. But if you go to any organization, majority of them, 98%, will be using one of these tools: GitHub, Bitbucket, GitLab. If you are using Azure, they may use Azure repos. In AWS, they may use code commit. All this works under line Git only. Okay. This SVN, Mercurial, ClearCase, they were all used, at least I have used at least 10-15 years before. So I'm not sure how updated they are, but the usage of these tools are very less. Well, it is just less than 5% in the overall enterprise. So we will be concentrating on these Git hosting services, and we will specifically be interested in GitHub, okay, because that's an open source. It's free for us to use. Okay. Any questions, guys? What is Git, why we need Git, and how we are going to do this? Okay. Let's talk about, now we need to install this, right? Now all this is fine. How do I install this Git in my system, right? So if you are in Windows, let's start with Windows. If you are in Windows, just go to this URL. Okay, let me paste this in the chat there. If you guys wanted to do it parallelly, also you can do it, not an issue. Okay, I will show you how to install Git in Windows. I will show you how to install Git in Linux as well. Okay, I will spin up a virtual machine in AWS, and then I will log in and show you how to install Git. Okay, so let's go here. I have already installed, but still I'll show you how to download and install. Just go to your browser, go to gitsem.com, right? See here, for Windows, it's very easy. Just say latest. So this is 2.38.0 is the latest one. Click for download for Windows. Automatically what will happen, you will get to this page, and whether you wanted a 32-bit or 64-bit, normally we go for 64-bit. Go and do a 64-bit setup, right? You download an exe. See here, there is an exe that is getting downloaded. I will take you through the steps to install it, but I will not install it because I already have it. But you can go and follow the same thing. Okay, let's go and do. So I wanted you to show some few things that you need to know what is there in that, right? Git for Windows. Okay. So you can go to next, leave all these things as default. Next, here, there are two things you can do, right? Either you want your master branch to be named master by default, or you want to change some name, right? Some people used to change some name, but for now, we will keep it as default as master. Master will be our master branch. If you want to override, you can override with main, trunk, development, whatever you want.
Chandra, can you make your screen little large? Zoom? Can you
Little
zoom it?
bigger.
Yes. Little zoom. That's mine. Is it okay?
Oh, can you see now?
I will.
No, can you see the Git setup window?
Yeah. Can.
Yeah,
But it's
this I
very
think I
blurred.
cannot make it big. Yeah, I
Okay.
cannot make it big. This one, so this is whatever size is there.
Yeah.
But only if I make it big, I'll be able to make only my browser bigger. Okay,
Okay.
so
Chandra.
let's keep this option as yes, the audio is on, Arundhati. Yeah, the audio is on. If you're having an issue, please try to reconnect. Okay, so we will just keep it let Git aside. So by default, it will be master will be our master branch. If you want to override, in some of the applications, you can see instead of master, they will have main. This is the place where they would have overwritten. So let's keep it the default, and let's use the OpenSSH, which is bundled with Git. If you don't want to use that, you can have any external, you can use this. It's up to you, but you need to provide the path and all those things. Let's keep this bundled OpenSSH. OpenSSH comes with this one. Then whether you want a default one, a rebase, or only a ever fast forward, just go with the default since we're doing for the first time. Okay, now these are all some of the experimental sub features that they built in. Don't enable anything. We are not going to use anything of those. Just leave it as it is and go ahead and install it. Once you install it, then you will be getting these two things, Git bash and Git UI, right? These are two things you will get just to check that if the Git has been installed correctly. Go to Git bash. Okay, this will just show you a Linux like kind of a terminal, and just go and say git hyphen version. See, this is what it will show you. For Windows, I have installed Git version 223, but that is not the latest version. The latest version is a different one that we downloaded, but still you can see 238.0 is the latest version. I have 223.0. Doesn't matter, you can download the latest one. Okay, so this is how you do in your Windows. It's very simple. You just need to go download the appropriate exe, double click them, keep everything default, and install it, and you will get this. And go and check for Git version and make sure it is installed. Okay, this is how you do in your Windows. Let's see how to do it in if you're having Linux operating system, right? Let's see that also. So I am creating a virtual machine in AWS and Linux machine, and I will use that to install my Git. Okay. I have my keys there. You have to go to the virtual machine. EC2 is a Elastic Compute Cloud, which is where you create your virtual machines, right? And go to the instances, and let's create one instance, and we will destroy it as soon as we are done, right? Okay, let's give a name of my this one, say Git server. I'll keep it as Amazon Linux. I'll keep it as all free tier, so we don't have to pay anything, right? And we have to have the key. This is the public key, which will be stored in AWS. Private key is with me. So when I need to connect to this machine, I have to pass this private key. If the handshake happens, then I will be allowed inside the machine, right? Let's go launch. Okay, so once the machine is in the running state, when you go and select this, there is a public IP. Using this public IP, you will be able to SSH, or you will be able to get into the Linux terminal. Then from there, you should be able to go and install all your stuff, right? Just give a minute. But make sure you have access to that private key. This is in running state now, so we should be okay. Let's copy this public IP, and here is the key that I have. 0201 PIM is what I attached, and that is what the key I have. So you have to use SSH-I. This OpenSSH is where it gets bundled with your Git, so it's you don't have to install your SSH again, right? So SSH-I is for identify. Okay, 0201 PIM, and the default EC2 -user is the username for this machine, and give the IP address, public IP address, right? So now you should be able to connect it. So hold on. Okay, can't be established. What happened? Host key authentication failed. Okay, it has to initialize. Just give a few minutes. Okay, fine. Now we are inside the Linux terminal now. Okay, now how do we go and install Git here? So let's go and see if we already have Git. I don't have Git. Okay, so I'm going to install sudo. Sudo means run as root. Sudo yum is the package manager for Linux. Red Hat Linux and Amazon Linux is yum. If it is Ubuntu, it will be apt get. That will be the package manager for Ubuntu. Okay, so since this is a Linux machine, we are going to use yum. Okay, yum sudo yum install git. Give a -y. If you don't pass -y, it's going to download and wait for your confirmation, and will ask you whether you want to proceed. You have to give y. Instead of doing that, just pass -y itself, so it will not ask for you. Let's go and click on this. Okay, see, it's installing git. There are 6 packages, everything installed. Just go and say git -- version, and just see what happens. Let me clear this screen. Git -- version. See, this is the latest version that has downloaded for Linux 237.1. And just go and click Git. It will show you all the stuff, right? So this is how you have to install this in your Linux. So that the instruction is already there. So this is basically for your it's Ubuntu Linux. Okay, this is Ubuntu. This is for Ubuntu. This is for Ubuntu. This is for Ubuntu. Whereas this one will be for your RHCL or Amazon Linux, right? And that will be yum. And we will make this one as RHCL is Red Hat Enterprise Linux. Okay. Okay. So now we have installed our Git. Any questions so far, guys? So Windows we have done, and in Linux also we have done. Okay. So let me come out of this Linux. Okay. Okay. We are here now. Okay. So what we are going to do, first we are going to set up a Git user. Okay, Git user we are going to set up, and we will use this Git user, Git config global username, and we will also set up our email address. So if you don't set up this, what will happen? This is what this is what whenever you check in, it will take this username and email ID. If you don't set this, every time it will ask for this. So we will do one time this setup, right? What we need to do. Okay, just give me 1 minute. Just give me 1 minute. Okay, let's go and do this. Now, before that, what we have to do, let's go and create a folder inside our Windows, and then we will get into that folder and we will start our Git, all those things from there, so that you have a separate folder for your code and everything, and you know what you're doing. We just go and do random somewhere, it's very difficult for us to go and trace that, right? So what we will do, we will go back to our, where are we now? PWD is print working directory or present working directory, whatever you want to call it, right? Okay, now where are we? We are in users and my name, right? Let's go create a folder called 0810 git. I'm creating a folder. Since this is a Linux based terminal, I'm using all Linux commands, or you can go to the Windows, right click and create a new folder. Everything is same, right? So file already exists. That 08 is for August, I believe. So let's make it this one. Okay. Okay, this is where we are. We clear the screen, do a PWD, and you will know where we are. We are here. Okay, let's go and first set up this. Once you install this, the first command is to go and set up this git config -- global user.name equal to give some username, right? Let's go and try this out and see. So you'll have to say git config -- global. So that means whenever you try to do any kind of this one, then it will take this name, right? Whatever name that you're giving, right? So this will be your username that will be set globally. Similarly, set your email address also. Email.
So Chandra, if we want to do in Windows system, we have to use CMD or maybe Git Bash. Then we have to do the same
Either
steps.
you
No?
can use anything you can use. It's up to you.
Okay.
It's up to you. I would prefer to use Git Bash, okay, because that comes with colors. Okay, so when you are seeing some files, whether it is tracked, untracked, everything will show in colors.
Okay. Yeah.
So that way it will be very easy for us to kind of find out if we have missed something to check in, check out and stuff, right? So that is where this happens. So this will be your first command. Okay, so this will be your first command. So the second command is you go to the directory wherever you want your this one and start initializing your git. Without initializing the git, nothing will happen. So the next command is to initialize our git inside this folder. Let me clear my screen, make sure always I'm there in the correct place, and go and say git. Before that, let me show you something. When I do ls-la, it will show all the hidden files. Nothing is there now. So now I'm going to run git init. And what it will happen, it will go and download certain files and it will put everything there. So that will be used to refer to your git commands, right? It has initialized empty git repository in, so it will create a local staging repository. So before we upload anything to remote repository, we will be checking in, checking out everything in our local repository, and then once we commit everything to local repository only, then we will be able to push it to remote repository. Okay, we'll talk about that going forward, but just to keep you, let you know, there is a repository created in the local. Now see, there is a folder called .git that has been created. So you can go inside this .git. Don't change anything. Please be very careful. Don't change anything. Okay, these are all some of the configurations and other things that are there by default, and it will refer. Okay, it will refer all these things there whenever we are trying to do something, right? So just make sure there's some of the hooks, right? You can go and see these are all some of the shell scripts that are there, which will apply when you try to commit your this one, right? All these things will go. Don't change anything in this. It's all by default. It will be there. If you change something, then if you really know, then you can go and change. Otherwise, it will not work. Okay. So just make sure you are coming out of those folders, right? We are 2 level down now. Okay, we are there. Fine. Now the Git has been initialized. Now what we are going to do, we are going to create some files. We are going to create some files. Okay. So there are multiple ways to create files. Okay, I will show you different ways to create files in Linux, and we'll also create few in Windows as well, right? So whoever is working on Linux or Mac terminal, you can use this. For Windows people, it's very simple. We have to just right click and create a file. So let's first create a file. One way to create a file is to do echo. You can write something there, right? Echo means it's just like throwing a ball and the ball will come back to you, whatever you say, right? That's echo. So echo is a command. Echo, this is first file, right? And what I'm going to do, I'm going to write this to a file called output this text. I'm going to just say this. So it will create first.text. And if you get into first.text, you will see whatever we have sent the string there. This is one way to create a file. Okay, this method is best if your content of the file is just maybe uh, 5 or 10 words, right? Not more than that, just a single line. This will be better. If you are trying to use more, it's very, very difficult. There are so many text editors. One such editor is called VI or Vim editor. Okay, VI editor. There is another editor called Emacs. Emacs is not available in my system. If you want, you can install Emacs and use it. There is a Nano, that is also text editor. We will use VI. So for a VI, we will use second.text. So you say VI second.text and enter. Okay, and you have to give I to insert the text, saying this is a second file. So to save this, you have to hit escape colon, see the colon there, W write and Q for quit, write and quit. Okay, now it will write and quit. You see here we have first and second. Go on cat this and see if you are able to see this, right? We have both the files now. Now let me quickly go into my Windows and create another file there, right? So these are the 2 or 3 ways to create in your this one. So it's very, very easy. If you are familiar with Linux, no issues. If you are
We
not
can use
familiar,
putty
also no
also,
issues.
right, Chandra?
Yeah, you
Using
can
putty also we can do that.
putty.
Putty is
No. Putty is used to just to connect to a Linux terminal. So if you have a Linux terminal like this, right? If you have a virtual machine or some Linux terminal, then you can connect it through that.
okay.
Here I'm connecting to my own machine, right? This is my own Windows machine.
Okay.
But this Git bash mimics a Linux terminal. That's all.
Okay.
It will just mimic that. Nothing else. Okay, nothing else it will do. Go back down somewhere. It should be there. I believe. Yeah, 10. Go inside. You see here the first and second. These both are created from as part of Linux commands. We'll now go and create a normal text document here, right? Say third. And go and say this is the third file, right? That's it. This is the normal Windows how we create, right? The problem with the Windows creating in Windows is multiple files creation will take time. You have to right click one by one and go. But my suggestion would always be to go with this git bash terminal and use some Linux commands. You will learn some basic Linux commands and it will be useful for you in the future as well. Okay, well, let's go and see now. We have 3 files now. Okay, now the git is already initialized this. So the first command that we are going to do is always git status. Git status is the first command. You go and see, it will say we have all 3 files untracked. Nothing has been tracked, no commits, nobody's tracking this file. So you will get it in red color. Okay, that will be your first command, git status. Okay, since we just created the file, it is not tracked, nothing is tracked, nothing is committed, nothing is tracked. Okay, to track a file, we have to use git add as a command. So git add, give a file name, or you can have git add dot. If you give git add dot, it will add all the files inside that area, staging to the staging area. Or if you just say specific file, it will only copy specific file. We'll do both, right? So what we will do, we will say git add. I want to add only first.text. Okay, add only first.text. Leave this warning because these 2 files have been created from Linux terminal and there is a format mismatch between Linux and Windows. Okay, don't worry, that's just a warning. Don't worry about that. Okay, now if you go and say git status, let me clear this screen. Please stop me if you're not understanding, right? See now, new file. This is already tracked, so it is in green color, and these two are not tracked. So to add that, you can just say git add dot. It will add everything at one shot, right? If you are having only one file, you are aware, just do only one file, or do a dot, it will do for everything. Now what has happened, we have created the file, we have tracked the file, and we have added it to the our staging repository, which is in our local, which we initialized, right? So it is in our local repository, but we haven't committed. We have just added the file, we haven't committed. Only after we commit, we will be able to move it to the remote repository. From remote repository only, others also will be able to collaborate. Right now, all these files are still sitting inside my machine, my local machine, right? My local machine. Nobody is able to access these files. Okay, so you have to track this file, add this file, and again just keep a hold of this three commands, right? So git status, git add, and then git commit. So these three things, right? These three things are very, very important. So these three you will be using over and over and over again if you are using Git, right? So these three commands you need to know for sure. Okay. And every time in Linux, if you are working in Linux, always have the first command done as pwd, which is print working directory or present working directory, and ensure that you are in the right folder, right? Ensure that you are in the right folder, right? Always put this so you know you are inside right folder. Okay, so now we have done this. Now let me go and create another file. Okay, echo and say this is fourth file. When you just do one arrow mark like this, right, you are outputting, you are creating a new file. If you again write another line and single greater than to the same file, it will delete the file and create a new file. If you want to append any text, you need to put double this one. Okay, so for now, since we are going to create fourth.txt, now I want to add another line in this fourth file, second line. Then I have to have like this. Then if you go and do a cat of fourth, then you will see two lines. It will get appended like this. If you don't do a double this one, it will overwrite that, and it will have only the second line. Okay. So just for your this one. So now if you go and see again, if you see this is not added. Yes, see, everything is added. The fourth is not added. That means you are still working on it. So once you have worked on it, all the code, just go and do a git add and either do a dot or a single file. That is also fine. So this is where your git add will come. Now let's talk about git commit. You are committing to the local repository. To commit the staged files to your local repository, it should be git commit. So how you will do this is git status. Okay, everything is fine now. Go and do git commit, and you have to give a commit message -f. Without commit message, you will not be able to commit any files. So you can say my first check-in, say enter. So see, it has created in our local staging repository. It has committed all the files here, 4 files. Okay, all the 4 files. Now if you go and do git status, see, you should get this, nothing to commit, working tree is clean. That means you have committed all the files correctly. Okay, if you don't get this and you're getting something, there is some problem with one of your commands that we used it here. So always keep this in mind. Should be a message here, should be some commit messages. So this is where people will say what I have changed for what release and all those things, they will give it here, right? So this is what you need to give the commit message here. Okay, so these are all some of the basic things you need to know for Git, to work with Git. So why we are learning this, even though I'm not a developer and all those things, when we want to write automations in DevOps, we need to trigger some automation integrations, right? So we need to know this, and we will be pushing some files to trigger that. Without that, we will not be able to do it. Okay, and here to stage and commit multiple file at once, you can use a flag, -a. You can use a -a flag. It will stage all the files and commit to the local repository. So instead of doing add and commit, you can do a -a flag. It will do both, but I would always recommend to please do separately, because sometimes we will add it, we will not stage it now, we will not commit it now, right? So it's always better to do it as a single command. Okay, fine. Any questions so far, guys? So now still we are working only in local repository. Everything is in my local repository. Everything is in my local repository. You cannot see the repository. Okay, just for your information, you cannot see the repository, but these commands will go and actually commit those into the local repository. Okay, now let's go and make one change, right? Say second line in first file, right? Okay, now assume that everything is fine. Your manager asks you to, there's a new feature you are adding and you have made the code change. Now what will happen, right? What it should happen? It should say it is modified. It is modified, and it's not saying it is not tracked. It is modified now. So you can go and do git add and commit and do all those stuff, right? Put whatever message you want to do, right? Put this, everything will be like done. See here, one file changed, one insertion. Okay, now if you go to git status and see, everything is fine, right? So this way that you can modify, add, and you can commit and you can do all those things. See this line, what we have done. See here, git commit. I have added and committed my thing at the same time, just to show you that command also works in a single command. Instead of doing a single command, you can do a combine. You can do one command also, right? But my preference would always be for you to do git add separately and git commit separately, so you are aware what you're doing, right? Okay. Any questions so far, guys? Okay, that's fine. Okay, that's what we saw. Now let's go and do how to stage and commit multiple files and how to remove commands and how we can delete the file. Like there are two ways to delete the file. Either you want to delete it in the local repository as well as your local folder, or you want to remove only from the repository but not from your system, and we will go and see all those things, right? So let's take, that's why I just created so many files, right, for us to go and keep on working on this. So let's do git rm is remove file, git remove file name. Let's put some git remove file name. Let's go and see what are things that we have. Okay, let's say git rm, and I want to remove third file. Okay, just something, remove third. Okay, now if you go on ls, there is no third file is gone in your repository as well as in your local system. In both it is gone. Okay, now if you go and do git status, you can see it has been deleted from the staging also, staging repository as well as your local file system. It is deleted. Now let's have this also, right? The dot text. Okay, okay, do git commit and do a -m, say third commit, whatever you want to put, but give some meaningful messages. Since we are just learning now, we are giving some random, but when you go into your project, you have to exactly say what changes you have made to that file, so that others can see the commit history and they will know what you have done and who has done this. Okay, so third commit. Okay, it's done now. So now if you go and say git status, it should be clean, right? Everything is clean now, right? So we are clean now. So we have restored this back. Now I want to remove the second only from the staging, but not from our this one. So for that we will have to use rm -hyphen cached. So that will remove from the repository, but not from the local system. So let's say git rm -hyphen cached and give the file name as second.txt, right? Now what will happen? You see still your second.txt is in your folder. Okay, but if you go and do a git status, see what happens. See, it's deleted your second.txt. Okay, and this becomes untracked now. It is deleted in the repository. It is not being tracked, so it says untracked. Okay, so this is how you can kind of remove it from your repository, but not from your local. See, we will not be removing from local. Okay, that use case is very, very less. The use case will always be removed from the repository. So this cached option is where you will be using quite often. Okay. Let me put a pause here. Any questions, guys?
A bit confusing, but I don't know. We need to do practice. I think so.
Yeah, it's very simple. Once you do this right, I think you should be able to get it right. Because now we are seeing all the commands in one shot. It might be confusing for you, but please go back and please work on this. Take a look at this video and the PPT and work on this few basic commands at least, right? Then you will get the hold of it.
Okay. Okay, Chandra.
Fine. Let me just make sure that we commit this guy also, right? Put something. I want to make sure that guy is also inside there. Let's go and see. Okay. Git. What happened? I did something wrong there. Okay. Nothing added to commit, but untracked file present. Let's go and do, because we deleted the file from repository. So we cannot just go and commit it. We need to add that and then we will need to commit it. -m is the option to pass the message. So just make sure. Okay. So go and make sure you're having git status. So keep these 3 or 4 commands in mind always, right? So whenever I ask you, you should remember these commands, right? I'll wake you up in the night also. You should say, oh, you have to do git status first. You need to do a git add commit, right? So these are the basic commands you need to know as any developer or a DevOps engineer, right? Okay. Now let's go and see the other interesting one, right? Now there may be a lot of files that you may be working, but you don't want to track some of the files. So if you don't want to track any file, then you need to create a file called git ignore and put those files inside that will not get tracked. Say for example, JPG or some documentation, some README files that you are having, which you don't want to track in your as a part of a source code. Always the source control system should have only the source code. It should not have all junk files that is there in our folder, right? Let's go try this and see. So say for example, okay, let me create this as abc.class, right? I'll create a folder called class file. Class files are nothing but files which are created when you have a Java, you compile, it becomes a binary class file. Okay, assuming that this is a Java file. Okay, and I'm going to create this as class file. You see here that is still there, but if you go to a git status, it will be there as ABC class. So what we'll have to do, we have to go and create a git ignore file. Okay, let's create a git ignore file called .vi.git ignore. .git ignore. Whenever you create any file with the dot, it will be a hidden file, so you cannot see that. If you simply do a dir, you will not be able to see that. Okay, git ignore and say star.class. All files ending with .class, please ignore. Don't commit it. Okay, don't commit it. That's what will happen. Now go and say git status. You need to commit this one also. You need to add this also. Okay. See here already that is ignored. So it's not saying you need to add git add that class file. It's not showing because it is there as part of the git ignore. So do a git add dot and go and do git status. So this you will not know until you kind of push it to the remote repository. You will not see this effect, but this is what we need, right? So let's go and commit. Okay. Get status, nothing to commit, everything is fine. So now I have abc.class. Let me create another one called def.class as a file, right? Some class file, and we'll just put def.class. Okay, and go and do a git status. See the difference now. It's already in the git ignore to ignore all the files that are ending with .class. So it's not even taking those changes whatever we make for def.class or abc.class. Now if I go back to def class and say second line, I add something, right? I add apples, right? Apples, and put it in the abc.class. Okay, now if I go and do git status, since it's already part of a git ignore, nothing, it will ignore, it will not track that at all. So this is the git ignore is a file where you need to use to go and ignore any files that you wanted to ignore from this one. So this is .git ignore, and you can see here, right? So you can go to .git ignore. See, class, you can give a specific folder path, or you can give a specific file name, or you can give all the files ending with class, all the files ending with jpg, all the files ending with doc. Everything can be ignored, right? You can say that. Okay, so this is a way how you can ignore some files also, right? This is how you go and do a git ignore. So it can be any star.class or any files, right? Any files for that matter. You want to, for example, let's go do one more thing. Let's do vi git ignore and go do an I, go to the end, enter, and say start dot all the files ending with what do we say, something, right? ASP, for example, ASP. I don't know what format is that. I'm just making it up. Okay, so let's go and say ASP. Okay, go and do a git status. See, it will only show that you have modified the git ignore. It will not use that. So just go and add the git ignore file and commit that git ignore file. The next time, if you see, all that will go off, right? Right. Now go and do git status. Everything we are clean. Now if I go and make a same changes, right? You have one facility in this Linux like terminal, right? Do a control R. You can do a reverse search, and you wanted to do a this one, right? This is what we did, the last one. Okay, so we can just have like this. You want to go to the previous commands, you can do that one. So if you haven't learned Unix or Linux, basic Linux, my suggestion would be to please learn that, right? See, even though we have xyz class, that is also ignored now. Okay, so this is how it happens. Okay. You can ignore certain files there. Okay, any doubt here? Now there are certain things we need to do local, then we will go and create some users in the remote repository. Okay, what are how to see all the commit logs that you wanted to see, right? Just go to git log. See all the commits that we have done so far, everything is, see the username and the email address that we set up initially, and what is the commit, everything you can see here. See here, my first check-in, Saturday, October 8th, what time, right? Who is the author, and who is the, what is his email ID, and what is the commit ID. This is a 56 characters commit ID, you will get it. Okay, so all the commits that we have done so far, we can see here. This is the last one that we have done. Okay, so now it's very difficult for us to see, so you can go and see everything in one line, right? Just only the commit ID, and it will give you the commit, right? We can go and see what is that. If you don't have if you have very big commit It's very difficult to search, and this is how you can go in. Whenever you say head master, it is the latest commit. It is pointing, the pointer is on the latest commit. These are all the previous commits that we did, right? First check-in, second check-in, third commit, new commit, ignore. This get ignored is the last one. So this is one line. You can do like this. It will just give you 5 or 6 characters from your 56 characters. But if you go ahead and do in git log, it's very, very difficult for you to search. So the best way to do, suppose in case your manager asks for everything, you need a better way to go and analyze this is do a git log and output that to a log.class file, some files, right? And go to log.class. You can see all the commits, and you can go through, you can search and let your manager know whatever happened, right? So that is the way to do. Okay, so like this you can play around however you want, but my suggestion would be to make sure you use git log or one line. If you are only doing a handful of commits, it's easy to go and search using git log. Otherwise you have to go for one line. Okay, say for example one of your team member has said that he's on vacation, and you are calling him and asking, hey, we want to immediately change your code. What was the last commit you did? He may remember some word, right? He may remember, okay, I made changes in the label button, something, I put some label button, right? Then you can go and search on this one line and take that commit, and you have that commit ID. You know whether it is committed or not, it is there, right? So that's how you can search. Okay, you can also, if you know Linux, you can do this also, right? Grep my. So you're passing this git log command, you're piping it to another command called grep, and you are searching for the word my. See, only the two commits are there with my, right? So you can do a lot of stuff, right? It's if you have learned Linux and stuff, it's you can keep on playing around, right? But at least from the git's point of view, this is what you need to know to see any commits, like git log, right? Git log and git log one line, and there is some, you can decorate and you can have some graph. You need to put some plugins for this. I did not put this, but just to let you know, if you want to see as a graph or some kind of a UI, some kind of relationship, right? It will show you. So you can decorate it as a graph. This mostly doesn't work, but there is a command like this. You can try it out and see. Okay. Any questions so far? Now we are done with all our local repository. So I have created my files. I'm able to add, I'm able to delete, I'm able to see all the commit logs. I am able to ignore some files. Everything is fine. Everything is in my local, right? Now we are all working as a team, but I have all my code in my local. How do I share it with you? How do we collaborate, right? That's what we need to create for our with our remote repository. Any questions so far before we?
Chandra, one thing, just want to know, like when you are using VI in the front, so whether that requires also the installation or directly it will come as a,
So if you are
we can
having,
directly
yeah,
use
if you are
that one.
having, yeah, if you are having Git Bash, or if you are
Hmm.
having a Linux terminal, VI is by default available for you.
By default. Okay, okay. Then
Yes.
I think it will
But if
work.
you are going to the command prompt, if you are going to the command prompt from Windows, you will not have VI.
Okay, got it. Yeah, thanks.
Okay. So let's talk about remote repository, right? So the users work on all, we all work on local repos. Now I have worked on local repository, and now none of my code is available to anybody, right? So we are all working as a team, but still my code is with me, your code is with you. But in order to collaborate with other people, we use some remote repository. A remote repository is a place where users can upload and share their commits with other collaborators, right? We will use GitHub as our remote repository. So first thing you need to do, you need to sign up at github.com. Okay, I've given you steps here. I've already created accounts there, so I cannot create this again, but you can go and create you can go and sign up in GitHub. Okay, and then you have to create a new repository. Okay, I'll show you how to create a new repository. Go to github.com. Okay, I have a lot of things there, so I will not be able to show you that. So what I'm going to do, I'm going to create a new repository. Okay, so I'm going to create a new repository. I'll call this repository 10008/git, like whatever I had, right? and you have two options. Either you want to have a public, anyone on this internet can see this repository, or you can choose who to see this. Now for private, you may need to pay some money. At the same time, private, you need to give access to the users who can see your code. For now, let's make it public and go and create a repository. Okay, this is what you need to do. After you create a repository, we need to link our local repository to the remote repository. So whenever I push my code, that will get pushed to the remote repository. We will go and see what we can do, right? Again, I already have a signed up. That's why I'm able to log in. You need to sign up first and then get inside and create your new repository. Okay, now let's go back and see what are the options that we have, right? So just go create your demo repository and some stuff, right? Whatever that we did now, it's already there. Private repository, you may need to pay some monthly premium, which I don't want you to pay, because we are simply going to only upload first, second, third, fourth, fifth. It makes no sense to anybody. Just for us to learn Git, that's more than sufficient. Okay, so the first thing, how we link our remote repository to local repository is using git remote add origin. Origin is an alias. Origin is an alias name to your remote repository. It can be any name. It can be any name, but by default is always they use origin as this one. Okay, so git remote add origin, or when you create your local repository, it gives you that command as well. See here, git remote add origin, and this is the your repository URL. Okay, just go copy this, paste it here. So what you are doing now, under this folder, whatever I'm going to commit to my remote repository, it's going to point to this particular remote repository from my local repository, and that remote repository is added as an alias name as origin. You can give whatever name you want, it's up to you. Okay, it can be any name. Okay, we can do this. Now let's go and change this also and see origin 1, 2 and put this guy, right? I have two aliases pointing to the same. Okay, now to see whatever things that we have, just say git remote -v will go and show you. See here, this is origin, this is origin 1, 2. So it can be any name, but if you are changing the name apart from the default one, make sure whenever you are pushing the code, it has to point to the correct alias, only then it will point to the correct URL. Okay, so both fetch and push will happen using the same origin. So this is the first step. This is how now we are linking our local repository to our remote repository. Once I have done that, I have to push all my code from here to there. Just say git push origin master. Master is your master branch, right? You can specify branch name also, but by default it is always master. Always a master will be created for you. So just go ahead and put it in the master. So git push origin master or origin 1, 2, both will work, right? Git push origin. So origin is where you are pointing to that particular, it's an alias name, that's all. And see here, by default you are in master account only. Okay, master branch, it's not account, master branch. Do a push. See, it's pushed now to new branch. Go back here and do a refresh and see all your changes are here now. All your changes are here under master, and even you can click here and you can see all the things that you have it there. Okay, now if there is another team member in US who wants to work on the same files, what he will do, he will come on the next day and go to this code, copy this URL, and he will say pull or clone. He will pull or clone this entire repository and make changes, and he will push it. Next day morning, I will come and do the same thing, right? So this happens in cycle, right? So this is how we have pushed. See, the last commits are here. Now let's go and see some changes that we can do, right? Any questions, guys? Just linking, create your remote repository and link to your local repository. Now here is the thing. Now what I'm going to do, I'm going to cat my first. Okay, that is the second line. So let's go and add what to say, let's say apples to your first.txt. Okay, I've added. So you have to, when you do a git status, it will automatically show that is modified. You need to add. So let's go to git add dot, then git commit. Unless you commit it to the local repository, you cannot push it to the remote repository. Okay, now I have not committed, but let's try to push and see what happens, right? Okay, see, you haven't committed anything, so it already says it's up to date. So you have to commit, only then it will get pushed. Unless it is not committed, you will not be able to push it. So let's go and commit, say commit added apples, right? Just put this guy and go ahead and push it to the master. See now what happens. See, that's already put the master. And if you go back to repository here and refresh, see on the first, this one, added apples, right? 16 seconds ago, we had one commit 16 seconds ago. Okay, so this is how you need to link your local and remote repository. Any questions, guys, so far? Want me to show anything? Please let me know. You can also do in the other origin also. Okay, so just to do that, git remote, go and check this, git remote -v will list all the origins that is actually set up for this repository. Okay, now let's go and do echo okay, and do it first, and then just go and say git add, then git commit -m, say okay. Now I'm going to do git push origin 1 2 is also pointing to the same repository, so don't worry about that. Okay, we are done. Okay, now go back here and refresh this guy. See on the first, it will be added oranges 26 seconds ago, right? So this is how you can use multiple. You can, if you want to put to multiple repositories, you can have multiple aliases that are pointing to different repositories and start pushing and pulling. Any questions here, guys, so far?
Chandra, one thing, like suppose the other person done some changes in your file, then we can find the difference which was earlier and the person who has changed it. I think there is some
Right,
comparison also, no?
right,
Where we can.
right. Yeah, you can go and check all the commits here. You can go and see the commit history. When you go inside, you can see the commit history. So these are all the
Okay.
commit histories that we have, right? See here.
Yeah. Here,
So you
red
can go and see
things will
this.
be coming if there is any change or something like that. Yeah.
Right.
Okay.
Okay, so this is how you can do it. Let's see what we have. Okay, so this is what, just whatever we saw there. And you can also see here, you can also create an edit file here. But when you go to your organization, you will have only read-only access here. Because what will happen, if I change something in first.txt, added orange, you can go here, click on this first text, do an edit here, and you can put grapes, right? Nobody's going to stop you. You can put grapes here, right? You can put grapes here, and you can go and commit here, and you can say added grapes, right? You can go and add grapes and do a commit here, right? You can do this, but in your organization, they will never allow this to do, because if you are making changes here, it is no way it will be in sync for others. Okay, so whoever is making the change, they have to make it in their local, only then they have to push it. Okay, so this is how you have to follow this rule, thumb rule, you have to follow this. Okay, to just to see all your what are the remote attached to your local repository, git remote -v will list all the aliases and repositories that are being set for you. And there is a fetch command. It command will copy all the changes from remote to local. The fetch does not affect the present working directory. It will not override anything. So instead of fetch, it's always advisable to use pull. Okay, let's pull this and see what happens, right? So what I'm going to do, I'm going to commit this here as added grapes. Okay, let me commit it here. You will be able to commit it. There is no doubt about it. You will be able to commit it. Just go to first.txt. You can see added grapes, right? But in our local repository, under first, we will only be having till oranges or whatever it is, right? We don't have grapes. Now, every day morning, we can go and say git pull origin. Okay, your origin is pointing to that folder. Assume that somebody there, they have made some changes. Here is where it will happen. Okay, please pull it from master. Okay, I forgot to give the branch name, so it should be master. So it's already got it here. Go and do a cat first. See, we got the grapes, right? So this is what we need to do every day when we need to pull. It will override all the changes in your local, and you start working again and go and commit it. And then the next day, your developer in the US will go and do the pull, and they will keep. So this keeps happening 24/7, right? That's how this development keeps happening.
So this will basically sync the master and your local also, like
Yes, yes,
with this
yes,
one
yes.
pull
So
and push. Yeah.
before starting your work, the first step is for you to always do a pull. So you will get all the latest changes the team has made when you are gone, right?
Yeah, correct. Yeah.
So then you start working and you check in before you leave. Okay, so this is what we have for fetch. Fetch will not affect your present working directory, but this will actually merge the changes with the present working directory. So it's always better to use git pull, not fetch. Okay, any doubt we have? So we are now able to merge from here to there and there to here and all those things, right? So those are also done. Let's talk about branches, right? Now what happens, right? My production is running, and that is a working code, and that's a first version of the code that is running in production. It is in the master branch. Now there is a new feature that has been added, and that they are asking you to work on. So where do I start? I have to cut a branch from master, and all the code from the master we'll have a snapshot in our new branch. We will start making changes in the new branch, and then we can merge it to master and release it. Okay, that's what we are going to see. So git branches is what we are going to see next. Right now, if you see here, we only have one branch. See, only one branch, that is a master branch. So we are going to create some branches and check. Okay, so let's go and talk about these branches. A project in its development could take multiple different paths to achieve its goal, right? So there are so many people, so many features coming in, so many people, so many teams are working across the same project. Branching helps us to take these different directions, test them out in separately, and then do whatever we want to, and then merge it finally once and then publish it. So branching is an integral part of any version control system. Unlike other version control, Git does not create a copy, but it will only point a snapshot to the changes. So it will only point the snapshot to the changes. That is why it will be fast. Suppose you have 1,000 files here and you want to cut a branch and you are copying the entire 1,000 files, then again it's going to take time, right? So it's going to just have a reference to the master. So this is a master branch. What we are doing, we are going to cut a branch from here, test, and make some changes here, do the testing, everything, then merge with this guy and release it. That is how we are going to see. Okay, so to create a new branch from your current branch, you can say git branch, give a branch name, it will create a new branch. Okay, let's go and see. See, I am in, before doing that, just there is a command called git branch. It lists all the branches that are available. Currently we have only master. Whatever branch we are in, that will have a star. Okay, we are having only one branch, master, and we are currently in master, so that master is showing us star. Okay, now let's go and create a branch for us, right? Let's say git branch, give some name of the branch. Git, I want to cut a branch from master. You are inside master, so after going inside the master only, you need to cut a branch. You cannot come out of the master to cut a branch from the master. You need to be inside the master. Let me call this as a develop branch, right? I am now creating a develop branch. Now the branch is created. Now again, please keep in mind, all these are happening in our local machine, local repository. Until we push this to the remote repository, this branch will not go there. See here, now I have two branches, but I'm still under master. How do I go back to the new branch? Just say git checkout new branch name. Git checkout new branch. Just watch out for this one. See, this will get changed after we run this command. See here, now switch to branch, develop. Now if you go to git branch, what it will happen now? Where will the star be now? The star should point to develop. So that means we are inside the develop branch. Okay. Now the branch is created, right? There is another command where you can create and switch to the branch at the same time. Git checkout -b branch name. So that will create a branch and get into that branch. We'll check that also, right? So we are in develop now. Let's say git checkout -b and give the branch name. I'll call this as a future branch. What will happen? It is created a future branch and switched. So that means instead of two commands, one command you can create and switch and do a git branch. Now you are inside future. Okay, so I'm able to now cut branches. Now all the three branches has all the future and develop branch both has all the files with respect to master, whatever we have, right? Let's switch back to develop. Okay, this is the develop branch. Okay, now these are all the files that were in the master, that is also in develop. Now I have got some new requirement, so I have to create some new file. Okay, let's go and create a new file. Let me call this as a d1.text, which means it's from development, right? d1.text. Okay, now if you go and do git status again, d1 is not activated. Okay, fine, no problem. And then go and do a git add. Okay, then do a git commit -m added file in develop branch.
Chandra, if we directly add git commit without this message, then also it will do the same function.
No. Until you give the message, it will not work. Just only git commit will not work. Git commit has to be with the message. See here, we don't have anything. Once we have something, then we can see here.
Okay, yeah.
Okay. Now we have this d1.text. So what we are going to do, we are planning to push this to our repository and see if we can get the new branch there. So for that, I know my git remote -v is pointing to whatever the remote repository we created. So I'm going to say git push origin develop. Okay, see now the new branch develop has been created. Go back here and refresh this page. You can see now two branches. See, develop had recent pushes. Now if you go to the master, there is no d1 file here, but if you go to the develop branch, see here, you can see a d1 file here. So that means from master we have cut a branch and we have done some modification that is only available in develop branch. Okay, so this is how you can go and create branches and you can start putting your new features into the branch. Okay, now again let's switch to that feature also, right? So we will know, we can do some play around with that. So let's go and say git checkout. I think there is a git switch also. Let's try this also, right? Yeah, you can switch also. There's a switch or checkout, both the commands are there. But now we are in future. So now if you go, since we have cut the future from master, it will have only the master's file. See here, it has only reference to the master. There is no d1 here, right? So let's go and say echo future and put this one to f1.text. right? And say git push origin feature branch. Okay, so now go back here and do a refresh and see, you should be having 3 branches now. You're having 3 branches now. Go to the feature branch. There is a problem here because what we did is we did not do a git add git status and all, right? So we forgot to actually commit this file. Let's go and add this file. Git add git commit -m. Okay, now we need to do a git push origin feature. Now we are done. Go back here and go and refresh this page. You should be able to see here under feature. We just had a new commit. Now future will have F1, your development will have D1, and then we will have the master without F1 and D1, right? So these are all different ways that you can create branch, you can check out, you can switch, and you can do all those things, right? Now, how do we merge these branches? Right now, I have made some testing team has cut a branch from master. They have made their changes. The DBA team has cut from master. They have made their changes. How we are going to merge everything and then push it as a single branch. So merging integrates the changes made in different branches into a single branch. So git merge is the merge name. The branch mentioned is merged into the current branch. So what we need to do, let's go and do. So what I'm going to do, I'm going to first merge future into development. Okay, let's do one by one. So I'm going to do future into development. So I have to come out of this one. I have to switch to develop. I cannot be inside a branch and try to merge it to some other branch. I have to go to the branch where I need to merge, and then I have to give git merge feature. Okay, it's fine. There will be a commit here. Let's do this. See, it has now changed. Now what you need to do, you just need to do a git push origin, do a develop. Okay, before that, you are inside develop. Okay, see, you have a F1 also already inside your this one. So do a git push origin develop. So now we have merged your future into this one. So before we refresh here, you can take a look. We are inside future branch, it's in F1. Okay, and if you go back to develop, it's actually merged. Actually, see here, F1 is under D1, D1 F1 under this one. Now to merge all these things into the master, all that we need to do is just switch to master and integrate this guy with master. So the master will have all the changes now. So for that, go to master before that and check nothing is there. No D1, no F1. Okay. So what we are going to do, we are going to do git switch to master. Okay, the branches switch to master. Now I'm going to do git merge. Two files have been added to master. Now go and do git push origin. Want to put origin 12, go and put origin 12 and say master. Okay, now go back to master and refresh this guy master. See, your master has both D1 and F1. Now this code is ready to be released to production. So we have to build from this code and release it to production. So you will have all the new features that are part of different branch, tested in different branch, and you are not disturbing the existing production. On the day of release, you will merge it and release it. Okay, this is what the merging will do. Okay, this is how you merge. After you merge, all changes made in branch 1 after merging will be available in the merged branch, the master branch. It will be available in the master branch, and you can go and delete this redundant branches after it is merged. So the merged branches can be deleted using -d flag. Git branch -d branch name. Unmerged branches. If you already have some other branch which is not merged, you can do with a capital T. Okay, with small t we can go delete it. Okay, delete the branch. So, and then you can delete the remote tracking branch also. You can go delete it like this. Git branch -d -r origin, and go ahead and say you can remove the tracking, and to remove from the repository remote repository, you have to do this. Let's go and do one by one. Let's go and first go and do this. Git branch -d branch name. Git branch -d. So just to make sure what are the branches we have these are the branches. So say git branch -d, give a name of the branch. Future branch is deleted, that will not get deleted there. That will not get deleted in the remote repository. So to delete in the remote repository, this is what we need to do. We need to delete a remote tracking. We'll start the tracking and remove it. Here you need to push the developer branch or whatever branch, then it will start untracking, and then it will delete the branch. So let's go and do -d -r recursively, right? For any folders that you have, you can do -r and origin / future. So deleted remote tracking branch origin. So now if you get into the future branch, no tracking will happen. Okay, no tracking should be happening, and then you should be able to go and delete the branch using git push origin space colon future. Okay, it's deleted the branch now. Go here and do a refresh. You will see 2 branches now. Okay, only 2 branches. So similarly, you can do for develop, and you can remove that guy out, right? So these are all some of the ways that you can go ahead and create branches, merge branches, remove branches, and all those things. But branching is essential for you to make some new changes to the existing code, and you have to maintain that. Okay. Any questions, guys?
Chandra, so you have deleted that feature branch. So from master only you have deleted, na? So if we go to the develop and delete it because it is under that also, then also it works.
It will work. Because you are not, whether you are inside the developer, you are inside the master branch or developer branch, doesn't matter, since you are giving the
Okay.
name here, right? What to delete.
Yeah.
So
Okay.
it
It
will
will
only
take
delete
as
that.
a name
Yeah.
and yeah. Okay.
Yes. It doesn't matter where you are. You don't have to
Okay.
switch and go. Okay.
Okay.
But
Yeah.
to remove any branch, you need to be out of the branch. You cannot be inside the branch to remove the branch.
Yeah. Got it. You can't be in feature branch and try to delete the feature only. Yeah.
Correct. It's just like being inside the folder and trying to delete a folder, right?
Yeah. Correct. Got it.
So sometimes, right, very rare occasion, 99.9% you will not get this. There can be some merge conflicts that can happen when the 2 files have same contents are modified and merged. So myself and the Bala are doing the same code, same line we are changing, and same time we are checking in. There can be some conflict. Merge conflict can happen. Okay, whenever merge conflict happen, there are 2 ways to do. There are some third-party tools which you can integrate with Git, and it will try to give you where that issue is, and then you can resolve them manually and then check in, or you can talk to the peer who is going to check in and give your change and ask him to add it and then check in. Okay, this is to avoid the merge conflict. So when you sit for your interview, when they talk about Git, they may ask about what is a merge conflict, how will you resolve your merge conflict, right? This is how we will resolve the merge conflict. So merge conflicts arise when two files have same contents modified and merged. I also have first.txt, you also have first.txt. I have 3 lines, you have 3 lines. Both are trying to change the third line and try to check in at the same time, right? You'll get a, or merge at the same time, you will try to get a merge conflict. Okay. In that case, we will have to make sure that we are doing this resolving only manually. Okay. So merge conflicts are resolved manually by users. Git provides different merge tools to compare and choose the required changes, right? But still, you can also use some third-party tools with Git merge tools. There are a lot of merge tools. You can use that, find the difference, make the change, and do all those things, right? So these are some of the things that you can use to resolve your merge conflicts. Okay. Merge conflicts arises on merging branches. You set a default merge tool before resolving the conflict. So you have GitHub or you have something before merging. You set up some third-party tool with your Git, so you can do that. Commit the resolve changes and merge the branch again. You have to do manually that, and this is most likely this will not happen because we are all working on different modules. No two people will be working on the same file, same module. If I'm working on login module, our Abhinav might be working in a payment module, or Bala might be working in, say, search module, right? We all will be working in different modules. Two of us will not be working on the same file, same line. That is very, very rare case. Even if that case comes, there might be some merge conflicts and we will have to resolve it by talking to that particular resource, and then maybe he will do the change for me and check in, or maybe he will do the first change, check in, then I will go and do a merge, right? So something we need to come into an agreement, and these conditions will occur very, very rare. Okay, just for your information. So this is where we are done with our Git tool. So we have seen the exhaustive, what are the things, so how to, what is it, how to install it, what is Git, how to install it, how to do all the commits and stuff in a local repository, how to create a remote repository, how to push from local to remote, how to link it, then how to create branches and how to merge branches, how to delete branches, and we saw all those details here. Okay, this is the first tool that in our DevOps ecosystem, right? This is our first tool. So this is our first
Yeah,
pipe. We have now learned about this tool. Then we'll try to integrate with the next tool.
yeah. Chandra, one thing just want to check with. Since we are creating every new branches from here, like using the this shortcuts and this one. So is it possible to create the branches directly from the Git also?
Yeah, you can create the branch there also. But as I said, when you go to your organization, you will never have
Mm-hmm.
access to this. These all will be only read only.
Mm-hmm. Yeah. Okay.
Okay, this will all be read only. Either somebody in the team is designated as a release configuration guy, and he will cut the branch for you and let you know, hey, for this release, we are going to use feature branch. We are going to use develop branch. Everybody need to check in and pull from develop branch. He will only do that. This is
Okay.
to
Yeah.
avoid everybody creating their own branch. They will create the branch and they will let you know. One of the guy will be designated to do that.
Okay. Got it. Yeah. Thanks.
Okay. But still, again, as a tool, you can do everything here. But when you go to the actual implementation, we will not be doing all those things. Okay. We cannot do this. We cannot do all these things.
Okay. Yeah. Everything will be vice versa, but as per the company norms and that, only
Right,
one
right,
thing
right,
should
right.
be done.
Because you should not, yeah, you should not be surprised when you go inside a company, start working and say, hey, Chandra told we can create, but I cannot create here, right? No, that's basically because you will get only a read-only access and you will not be given even access to this particular Git.
Okay.
Okay,
And
you will
suppose
only
we
be
want
given
to
access
give,
to your local.
yeah, and if we want to give any developer this path one, so we can give copy from
Yeah,
somewhere, no?
copy this URL, copy this
Yeah, to
URL.
give. Okay.
Yeah,
Yeah.
to give it to him, he can just, what he can do, he can go and copy. If I'm a new guy, right, I'm a new guy,
Yeah.
I'm not a part of your, I'm just joined today, and you're just saying I wanted to see your code. Don't check in, don't check out, just ask him to do something. You simply go and create something like this, right? Temp git something. Don't initialize git, nothing, right? Just say git clone. Okay, git clone and clone this guy. Okay, sorry. git clone. You can give this git clone. Where are we? I already have this.
Okay. So he will clone this
change
one and he
directory.
can verify.
You got to change the
Directory.
directory.
Sorry. Yeah, you're right. I have to change my
Yeah, you got
directory.
to change the directory. You can just you created it. You will not change.
Yeah, right. I have to change to temp git. Okay. Now if I go and do a clone, is where I'll be able to clone. See here, I'll be able to clone. If I go inside, I'll see that folder, whatever was there, and I can get inside. And whatever I make any changes here, right? Nothing will happen. Nothing will happen. Okay.
Yeah, it
Let's
will
do this,
happen
right?
only in
Let's
this clone part. Yeah.
when only if the git is initialized to that particular repository, all the changes will happen, right? So nothing will happen to this particular. So even if I do a git, even if I do a git status, also nothing will happen, right? It will just start tracking if you want, because that is a same origin, but nothing will happen. You can go and play around with this. Now this you can point to different repository and you can push it. So you can use a clone and you can go and see all these things here. Okay, but this clone we
Yeah.
will not be using. We will be only using pull. We only using pull. Okay, that's fine. So this is what we will be using to give to anybody, right? So suppose if I wanted to go to some GitHub, some site, and I want to clone something or something I wanted to do, I can simply go to somebody else repository and I grab this URL and I can clone it in my local and have the code. Instead of cloning, you can also do a forking here. You can do a fork. When you do a fork, it will clone from here to your repository. Okay, so you can do that as well. So it's up to you.
Okay. Yeah.
Go to the one that we already had. Fine. So this is what is our first tool, Git. So please try installing it and play around with these commands. Go through this video and this deck. I will share this deck and video. Please go through that, and also please make sure, since you have created your EC2 machine, please go ahead and terminate it. Otherwise, you will get charged. Select the server. Go and say terminate instance. No longer machine will be available. It is destroyed. Okay, just wait for it. You'll get the status terminated. Then you can log off from your console. It can be anything, right? For me, it is AWS, so I'm just using this. You can use Azure or any machine that you want. Okay, so tomorrow we are going to talk one of the important tool. It's called Jenkins, right? We're going to talk about Jenkins. Okay, we're going to talk about this tool. This is an integration tool, and we will see how to install this and what are the different things and what we are going to do after learning this tool. Not fully, at least 50% of this is any changes I make to my Git has to trigger some job in Jenkins, right? That's the first automation we are going to do. Okay, that we will be doing tomorrow. So we'll talk about this tool and we will learn about this tool and we will see how to, whenever I do a check-in here, right? I just check in from here. I check in from here something. As soon as I check in and push it to my remote repository, a job should be triggered. So we will see how to automate from this one to that one, right? So that is the first step. So what we are doing, we are going to learn these tools separately and we are going to integrate one by one and we will make a full automation. Okay, fine. Any other questions that you guys have? So once it is terminated, you can just log off. You should be fine. And the code to download Git is already there in the our PPT also, and I've shared in the chat also. If you need, you can take it from there as well, right? So everything will work. If you don't have the PPT, you don't have the chat, just go to Google and say Git download for Windows. It will take you to this URL. Okay, so that's what happens. Okay, fine. Anything else, guys, from anyone? I hope everybody has access to the share drive. If you're not having it, please share your Gmail address and I will give you access to that. Okay, any other questions? So please take some time tomorrow, maybe 30 minutes or 40 minutes of your time, and try to install this in your local and try to work on this, at least the basic commands. If you are not aware of branches and all those things, don't confuse yourself. Go and do only the basic stuff first, and then see if you can create a user here in this github.com, and then you can see if you can push your code to your remote repository. Then second step, go back to the video, check on these branches and try to run some. Nothing will happen, don't worry. Okay, nothing will happen. Just go, either your branch will be corrupted or your branch will be deleted. Nothing else will happen, right? So we don't have any big source code. They're all simply 1 2 3 4 5 some text files, nothing else. Okay, so let's try that and see, and let me know if you have any issues. And tomorrow we will start about the Jenkins and Maven and Jenkins. And as I told you, we will be using a Java project. So we will be using Maven. I already have a Java source code which you can use it. You can clone and use that if you need, or if you have some other code also you can use that. Okay. Okay. All right. Anything else, guys? So tomorrow also we will see how to install this in local as well as in Linux. Okay. Fine. All right. All right, guys. If
Thank
you
you,
don't have
Sundar.
any questions, then we will meet tomorrow at 6 p.m. IST. Yeah. Thank you. Thank you all. Have a great day. Yeah. Thank you.
Thanks, Chandra. Thanks all. Bye.
Thank you. Bye.
Thank you.